Let's look at associations in categorical variables. Here's a table that shows marital status and education level for a random sample. Suppose we want to know, are the proportions of married people different for various levels of education? That is there an association between marital status and educational level? So we're going to focus in on this table in the next few slides. Probabilities where we focus on just one group and imagine taking a random sample from that group alone are called conditional probabilities. So for example, suppose we want to find the probability a person is married given that the person is a college grad. In this case, we're going to focus in on the highlighted row of college grads, and we're going to pretend like this is our data that we're focused in on and find the probability there. Let's look a little closer. Now, this is different than looking at the probability that someone is married and college educated. That's going to be the number in the intersection of married and college. That's this green shaded region here in my Venn diagram. So this is the married and college educated. When we look at conditional probabilities, so the probability that they're married given that they are college educated, here we're going to focus in on the bottom here in this college educated circle, and then we're going to find what's the probability that they're married once we focus in on that circle. So we're just looking at this bit. Let's look more closely at the table. So suppose we wanted to know the probability that someone is married and a college grad. Well, we're going to look for the entry in our table that corresponds to married and college grad. That's the 98 here. It's the intersection of the college grad row with the married column. So my numerator, remember I'm going to have the number that are married and college grads on top, divided by the number in the sample space. And my sample space here is the total number of people surveyed. So my top we said was 98, and the total number of people surveyed here is 665. So I have 98 over 665, which if I plug that into my calculator, I get 0.147. Now let's try the probability that you're married given that you're a college grad. Here, I'm going to focus in on my total being college grads, and then my group that I'm interested in is the married. So I'm going to do the number that are married, which is 98, divided by the total that are college grads, because now that's what I'm focusing in on, given college grads. So 143, and we say that's about 68.5% or 0.685. Here's the notation that we're going to use for conditional probability. We draw this line between A and B, and that reads as the probability of A given B. Okay, so the thing that comes second is what you are given. Here we would write probability of married given college grad. Okay. Let's look at this example. So the probability of being married, given that you're a college grad, is equal to the number who are married and college grad, that was our 98, divided by the number who are college grads, the number in what we are given. So 98 divided by 143. again, that's the number of married and college grad divided by the number that are college graduates. So in general, the probability of being married, given that you're a college graduate, is equal to the probability that you are married and a college graduate divided by the probability that you're a college graduate. Now notice each of these has a denominator of 665. So when I divide these, remember to divide, that's the same as multiplying by the reciprocal of your denominator. So I multiply by 665 over 143, and these 665s cancel. And that's how I get the 98 over 143. So in general, we can calculate conditional probabilities using the formula here on your screen. So the probability of A given B is equal to the number of elements in A and B divided by the number of elements in B, which is the same as the probability of A and B divided by the probability of B. This formula is on your formula sheet, and you can use it on the exam. So let's look at some examples again. So here's our table. Let's calculate the probability that you are married, that someone is married, given that they are not a high school graduate. So here we are given not a high school grad, so we want to think of that as our universe. So I'm living here in the not high school grad. And so my formula says that's the number that were in the group that were married and, whoops, not high school grad. And now I see I highlighted the wrong row. Let's fix that. Not high school grad. So we went divided by the number that are after the line, the number in what we are given. So the number that were not high school grads. Okay, so what is that? Married and not high school grad is this entry here, the entry that corresponds to not high school grad and married. So that's 70 divided by the number that were not high school grads. That's the total of non-high school grads here. So 125. 70 divided by 125 is 0.56. All right, let's try this one. Second one. Calculate the probability that someone you choose is a college grad given that they're single. Okay, so now we're focusing in on the single group, which is a column in our table. So I'm looking at this column, and I want to know what's the probability that I choose a college grad given that I'm choosing from the singles. So that's the number of college grads that are college grad and, let's write it out, and single, divided by the number that are in my given group, so single. Okay, college grad and single is where the row and column intersect. So here is where college grad and singles are in my table, so that's 27, divided by the number of singles, that's 112. So I'm going to type that on my calculator, 27 divided by 112. And I get 0.241.